Good morning, students. Today we will study electric current chapter. These are the topics we are going to cover in this video: electric current, conventional current, drift velocity of electrons and current density, Ohm's law, resistance, resistivity, conductance and conductivity, temperature dependence of resistance. Let's start. What is electric current? We have known from the class 8 the definition of electric current. The electric current is defined as a charge flowing through any section of a conductor in 1 second. Any section means if I take a conductor, we won't take the time from one end of conductor to other end of conductor. This we never take it. What we do, we choose any one of the cross section inside the conductor, and through this cross section, what a charge passes, or the electrons you can say, or if it's a liquid, then both charges, negative and positive. What the amount of charges that passes through this cross section in 1 second, that is considered to be amount of charge and current actually, right? So remember, it's not time from one end to other end of conductor, it is a time for a certain cross section area anywhere inside the conductor and the charge flowing through it. So the formula is given as I equal to Q by T, you know very well. And if you take for the small amount of charge, it's dQ by dt. SI unit is ampere. Okay, how many types of current are there? You know very well. There are basically two, AC and DC. But DC also has two types here. Steady DC, that is current which does not vary with time. That is A graph. You can see the first one, A graph, that is straight. Right? Second is unsteady DC. That is varying current whose magnitude varies with time. Here you can see in the B and C, the value is changing but direction not changing. It's not going to the negative part of the graph. So this is unsteady. Steady one, you can see the example is simple battery cell which produces a constant DC current. Unsteady means you can say DC generator. We'll study later in the physics only. In that the value fluctuates. The value changes from the 0 to the peak value and again back. Second one is AC, that is alternating current whose magnitude varies continuously and direction changes periodically. So you can see in the D graph here, this you know very well, it's like a sinusoidal graph, it's a kind of sine or cos wave, you can say. Next, conventional current. Current, you know, okay, conventional current. Actually, here I'll like to know that, remember, there are 2 points. If you are doing a conductor, metals, there are free electrons. So current is due to the flow of free electrons. There is no movement of positive charge inside the solids. If you go about the fluids, the liquids, then in that the movement are because of negative as well as positive. It can be electrons, it can be the ions. Okay. Now here conventional current means what we choose direction of current, that is important. So conventional current is a current whose direction is along the direction of the motion of positive charge or opposite to the motion of the negative charge. That is electrons in case of conductors, under the action of electric field, that is positive to negative. So what is the direction of conventional current? It is from plus to minus. You can see here, and electrons flow in the opposite direction. Yes, minus to plus, right? And electrons movement we generally say as electronic current, and conventional current is opposite to electronic current. Drift velocity and current. Drift velocity is defined as a velocity. Actually, it's average velocity, because you cannot say that every electron will move with the same constant velocity. It's average velocity with which the free electrons get drifted towards the positive terminal under the effect of applied electric field. So you can see here, this is a conductor, battery is connected, the electrons move from minus end to the plus end. So what is the average, whatever is the average velocity, that we consider as a drift velocity. These are the formulas, we'll derive it later. Just remember, because we need to use it in the further coming topics. So drift velocity is given as a tau, or you can say the acceleration, a is acceleration, t it is tau, that is time. Okay. The next is Vd equal to minus e tau by m, and I equal to NAVD. These are certain terms. What are the meaning? They are mentioned here. Okay. You can refer it. Current density. Current density at a point within a conductor is a current through which a unit area of conductor around the point, provided the area is perpendicular to the direction of the flow of current at that point. Density you know very well. It is either per unit dimension, length, area, volume. So current density, it is per unit area. So J equal to I by A, and if you put the value of I The value of I is NeAVD. So if I put the value of this, I is cancelled, so we can get easily NeVD as value. So in vector form, if we take, it is J dot I. Okay, now Ohm's law is a very important part, and you have studied from the class 8 onwards. Electric current flowing through conductor is right proportional to the potential difference across the two ends of the conductor when physical conditions such as temperature, mechanical strains, etc. remains constant. Remember, physical parameters must be constant. In that case only I is proportional to V. So further, if I take I proportional to V, we can take it as a V proportional to I also. If I take a constant, we get R, that is resistance. And the ideal graph of the metal for the metal conductor is, in certain cases where the physical parameters are constant, it is proportional, so a straight line. Okay. Resistance. What is resistance? It is a property, okay, to oppose the flow of electrons in the conductor, right? So R equal to V by I. Now we know very well the formula of current at I equal to NeVD. This value if we replace into the further part, okay, and solve it, we get the value of resistance, that is R equal to ml upon Ne square A tau. Okay, you can refer the derivation, you can easily understand. It's only nothing but replacing values into other. And we know R equal to rho L by A. So if you put the value of this R here, you'll get the value of rho, that is m by Ne square tau. Now the main point is here to remember, generally studied in class 10th, when they ask the dependency of resistance and resistivity, we used to go on the formula R equal to rho L by A and rho equal to R A by L. Generally R is okay. If you go at the formula, it depends on conductor, it depends on the length, it depends on the area, that is dimension of the conductor. But if you go at this formula, rho depends on A and L. It's completely wrong. Remember, A does not depend on dimension, it depends only on the type of material and temperature. So here, how to prove it? This is a formula to refer it. You can see here, there's no dimensions of conductor, neither area nor the length. So it depends on the mass of electron, it's constant. Number of electron, that is N. Number density, that means conductor type. Obviously conductor type is copper, iron, which different types are, it depends. Electron charge, and tau is temperature. So time, relaxation time. Okay. So just refer this, and remember, resistivity is completely independent of area and the length. It depends only on metal of conductor and temperature. Okay, next. Relation between Vd, rho, I, E, J, V. What are these terms? You know very well. Vd drift speed, resistivity, I current, E electric field, J current density, and V voltage. So it's nothing, just simple replacing values you can see and find out the rho value, Vd value, okay, J value and E value. This is simple, remember. Conductance and conductivity. Conductance is reciprocal of resistance, and conductivity reciprocal of resistivity. Conductance given by G, that is 1 by R, and conductivity given as sigma, that is 1 by rho. So you can take the units of R and rho, and you can understand the units are 1 by ohm per ohm, or you can say mho. Same way conductivity is mho per meter. For the temperature dependence is general form like alpha, that is RT. These are the values, these are the conditions mentioned here. You can refer it. It's simple like a formula of the class 11th, linear expansion of thermal expansion, linear thermal expansion, that is alpha equal to L2 minus L1 upon L1 del T. Temperature change. Same way here also, RT minus R naught upon R naught T. RT is resistance at high temperature, R naught is lower temperature, and T the temperature difference. Okay, next. Color code of carbon resistors. This is a very important part. One mark question generally asked in the board exams. So there is a certain method. What we do, in this there three color rings are there, and the fourth one is far. Okay, these three are any of the color from this table, and the fourth ring is this three: gold, silver, or that either you will not find any kind of ring that you can see in this example. Okay, now what to do? Very simple. The first ring, it shows The first one, like in this case it is B, so it is 7. If it is blue, violet, blue. So first ring is blue, it is 1. Second ring is violet, that is 7. And third one is again, sorry, it is brown. So it is black, so this will be 0. So simple thing, 1, 7, this is unit 1, this one tens, and this one is power 1. 17, 10 power 0. And the last one is gold, the tolerance is 5%, so it will write is plus minus 5%. Tolerance means the value of resistance can fluctuate 5% either high or low from the standard value. Okay, there's one more method to find resistance or to indicate resistance. This is not in your course, just for your knowledge I have given here. This one here, the whole resistance is at single color. At the two ends there are same colors, and one ring you'll find and one dot you'll find here. So just refer this, you'll get the idea how it is measured. Okay, thank you.